In this video, I'm going to cover section 10.3, the ellipse. So when we start the ellipse, let's tie it into something we already know. Let's go back and let's talk about the circle. All right, let's think about our friend the circle. Now we've met and used extensively this circle when we did trig, right? The unit circle. This is a circle that we're very used to. X squared plus y squared equals 1. But that's not the circle we met in Algebra 2, and that's not the circle we met at the beginning of pre-calc. If you remember back at the beginning of pre-calc, we met this circle, x minus h squared plus y minus k squared equals r squared. That's the circle we met at the beginning of pre-calc. And if we think back, we talked in pre-calc at the beginning of this class how this is just the Pythagorean theorem, right? It's somebody squared plus somebody squared equals somebody squared. It's the Pythagorean theorem. It's the distance formula. And so we learned that for this circle, the center was HK, and the radius was R, right? That's what we said, and we were able to draw the circle. Now, how did we draw the circle? Well, let's do an example. Let's do an example and just talk about a problem with some numbers in it, right? Let's say we have x minus 3 squared plus y plus 1 squared equals, and we'll make this 16, which of course is 4 squared, okay? So if we had to draw this circle back in chapter 1 of our pre-calc book, we did problems just like this back in chapter 1. We said, okay, our center is 3, positive 3, because the minus is in the formula, positive 3, negative 1, and we said our radius was 4, right? 4 squared is 16. So what did we do back at the beginning of school? Back at the beginning of pre-calc, we went this way 3, right? We went this way 3. We went down 1, and we said, okay, this is the center of our circle. Now, an easy way to draw the circle, right, is not to draw it now. I mean, if we had a compass, we could take our compass, we could put it on here, we could measure 4 by putting the point here and striking an arc like we did back in geometry. And then we could take our compass, put it here, we could draw our circle of radius 4, and we'd be done. But we don't have that ability in a pre-calc class. So what did we say to do back in the beginning, right? This is in chapter 1 of our book where we learned this. We said, well, if we start at the center of our circle and we build a box 4 units each way. So we went 1, 2, 3, 4 this way. 1, 2, 3, 4 this way, okay? And we built a box. We'll just use this as our straight edge. So we just drew a line like this, and we drew a line over here like this. And then we went 4 up. 1, 2, 3, 4, right? Those are way too close together to make a box. 1, 2, 3, 1, 2, 3, 4, right? So we have a line up here. And then we went 1, 1, 2, 3, 4 down here, and we drew a line down here. We end up with, it's supposed to be a box. I didn't work very hard at making it a box because I didn't measure anything. And then we said back, if we drew arcs that went around like this, we would get a circle. But that's a terrible circle. In fact, it looks more like an ellipse. And I would like to say, well, it looks like an ellipse because, no, it looks like an ellipse because I drew a terrible circle, okay? But this is how this box, right, this box was 4 units this way, 4 units this way, because the radius of our circle is 4. and it went 4 this way because the radius of our circle is 4. Now our box went 4 units this way and 4 units this way because the radius of our circle is 4, and the radius of our circle is supposed to be 4, but my circle's terrible. This is how we learned to graph circles. This is what we did. Now, if we didn't learn to draw the box using the radius, that's okay, because we've got it now. We see, wow, when I look at that on the screen, that is not a circle. But it gets the idea across. And the idea is, I'm going to relate circles to ellipses. We're going to draw ellipses just like we draw circles. So I'm going to erase a little bit here. I'm going to get this off here because it's just downright embarrassing. I'm going to take this off as well, right? Get rid of those things. And we're going to go back and we're going to look at our equation of our circle, and then we're going to compare that to the equation of the ellipse. Okay? What does the equation of the ellipse look like? Well, how is an ellipse different than a circle, right? A circle has a radius of 4. Well, an ellipse, if we draw an ellipse, right, an ellipse goes like this. What's different? Well, it has a center. This distance and this distance are equal, right? These are congruent, as we would say in geometry. This distance and this distance are also congruent. But they don't equal each other anymore. See, for a circle, these distances, these 4 distances are called radii, and they're all equal, and we get a circle. But when we make one of them shorter than the other one, we get an ellipse. So going from this formula to the formula for a circle, to the formula for an ellipse, is not a big jump. Ellipses aren't this brand new thing. So if we write the formula for an ellipse down, right, the formula for an ellipse, what is it going to look like? So let's talk about the ellipse. And what you and I need to keep in mind is it's going to look a lot like this formula for the circle right here. It's going to look a lot like that. We're going to have a center, so we're going to have an x minus h squared. Okay? Because h is going to be our center. Plus y minus k squared. That's going to be our center. So that's going to look the same. Now, what's going to make it different? Well, we're not going to have a radius of r. We're not. So we can't say equals and have a number over here. That's not going to work. Because if that's the case, we're going to be back to this formula and we're going to have a circle. And maybe in the homework they sneak one of those in on us and we draw it and we're like, oh my gosh, that's a circle. I should have saw that coming. So what's going to be different? Well, let's take this formula right here and let's do something to this formula, right? I'm going to rewrite it over here. I'll write it in blue since we're talking about the circle again. Let's just write it as x minus h, right? Like we did squared, right? That's this. Let's write it like this. Y plus, I'll make that a minus. Y minus k, right? Squared. We're going to write that as r squared. And now, what am I going to do? I'm going to come back and I'm going to divide over here by r squared. And that means I have to divide here and here by r squared, right? If we divide one side, we have to divide the other side. That's the rule. Well, what's r squared divided by r squared? And that's 1. Now, if I erase this piece, look at the formula for our circle, all right? If I want to make it equal, instead of equal to r squared, I could make it equal to 1 by dividing everybody by r squared. Now, why would you do that, Mr. Rainier? That's what you asked. Well, what's the purpose of that? For the circle, nothing. There is no purpose. You don't need to do that. In fact, we never taught you to do that because you didn't need to do that to draw the graph. But these values are not equal for the ellipse. So when we write the ellipse, there's going to be a 1 here. There's going to be a number under here and a number under here, just like this. It's going to look just like the circle. Remember, the ellipse, very similar to the circle. But we can't call it r and r because they're not going to be equal. So what do? We call this one a squared And we call this one b squared. Okay? Now, this is the equation of the ellipse. Right? We don't need to worry about where it comes from. We need to know that this is an ellipse. Okay? And what do we know about this ellipse? We know its center is HK. And we find it just like we found it with the circle. Okay? Now, what do we need to know about the A and the B? And, well, if you remember from Algebra 2, they're important to us, right? They're important to us. The A and the B are important to us. They have something to do with the major axis. The major axis. So what do we say? All right, what do we say about this? Well, we say if A is greater than B, okay, A is greater than B, then the major axis is parallel to the x-axis. All right, now that's not hard to remember. Look, the bigger one's under x, so the major axis parallel to x. And of course it goes if, right, if. So, well, I tell you what, we're just going to write that down. Well, let's just go with that right now. So, what are we going to say here? We're going to say this. We're going to say this. So here we go. We're going to say the major axis, and that's what we care about. And we're going to talk about all these parts in a second. The major axis is always parallel to the x-axis if the larger number is under the x squared term. Okay, the major axis is always parallel to the x-axis if the larger number is under here. However, it's going to be exactly what you're already thinking. The major axis is parallel to the y-axis, right, if the larger number is under the y squared term. So, what we need to know is the major axis, the bigger of the two axes, is parallel to x if this is the bigger number. It's parallel to y if this is the bigger number. That's it. That's all we have to remember to draw the graph. So, this looks a little confusing, right? But it's not. It's not. We're going to do some problems, and we're going to see that this is really not that confusing at all. So let's do some examples, and let's see how this plays out for us, right? So what's our homework going to look like? How do we take these ideas and incorporate them into actually getting problems correct, right? Because that's what we want to know. We want to know how to get the homework done and how to understand it so we can pass the test. So it's not going to be as bad as it sounds. As long as we keep in mind that the ellipse is like the circle, we're going to be fine. So let's take an example. Let's just jump in and grab an example. We'll take something like x squared divided by 9 plus y squared divided by 4 equals 1. Okay, so this is our first example. And what are they going to ask us to do? Oh, they're going to ask us to do all kinds of things. We'll write over here what they're going to ask us to do. Right? They're going to ask us to find the center. Okay, so what are they going to ask? They're going to want the center. They're going to want the major axis. Well, if we have a major axis, we have a minor axis. They're going to ask us about that. They're going to ask us for foci. Okay? An ellipse has 2 points, 2 focus points. Okay? 2 focus points. So they're going to ask us for the center, the major axis, the minor axis, and the foci. And of course, they're going to ask us for the graph. Right? They're going to ask us for the graph. Now, you know my theory. My theory is if I draw the graph, I can find everything else. Right? The graph, they always ask us that last, but it usually should be the thing we do first. So let's take a look and see how this is going to work out for us. Okay? Now, what do we know? We know A is always bigger than B. Okay, make sure you write that in your notes. A is always bigger than B. Always. So what do? We rewrite this and make it look like our formula. We make it look like that x minus h. In other words, we rewrite it like this. I need an h, so h is going to be 0, so I'm going to write that like that. Okay, that tells me where my center is, so I can see it. It's right there. Now that's supposed to be somebody squared, so that's going to be 3 squared. Now this is supposed to be y minus somebody, so I'm going to put a 0 in there because that tells me where my center is. Now that's supposed to be somebody squared, so I'm going to write that as 2 squared. Equals 1. Okay, now I'm going to draw the graph. Okay, I'm going to cheat. I'm going to draw the graph first. It's the last thing they asked me to do, but I'm going to draw it first. I'm going to draw the graph first. So I'm going to come over here. We're going to draw our graph. Now, where is our center? Right? We can see it. We can see our center. It's right there. Our center is 0, 0. So that's my center, 0, 0. So I'm going to put a dot there. Now, A is always the biggest one. So A is 3, B is 2. So what do? A is under X in this case. So this is a 3, so on the X, from the center, I'm going to go in the X direction 3 units. Okay, and I'm going to put a dot. Okay. Then I'm going to go in the Y direction 3 units. Sorry, I'm going to go in the X direction the other way, 3 units. 3 is under the X. A is 3, it's under the X. B is 2. B is under the Y. So we're going to go 2 units in the Y direction. We're going to put a dot. And we're going to go 2 units in the Y direction. And we're going to put a dot. Okay. Now, what are we going to do with these dots? We're going to use those to draw a box. Okay? We call this the box method. So we're going to draw a box through there. And draw a box through here. Going to draw a box here. We're going to draw a box over here. Now, why did we draw the box? We drew the box because it's going to be easier to draw the ellipse now because we have the box. So now that we have the box, we can draw the ellipse. We're going to start here. We're going to come down to here, come down to here, come up to here, and come up to here. And we get our ellipse. All right? So graphing the ellipse is really not the hard part. Graphing the ellipse, I know that looks terrible. Hold on, I'll fix it. There. Graphing the ellipse, once we know our box is very, very important. And the way we draw our box is we literally look under the X and go, okay, whatever number this is, I move that way in the X direction. Whatever number this is, that's under the Y, so I move that way in the Y direction. There was the 3 squared under the X, so I moved 3. There was a 2 squared under the Y, I moved 2. That's all I do, and I draw my box. Okay, draw my box. That's what they asked me to do, I did that. All right, so in terms of the graph, we have to label some points, right? We've got to label some points, but we know points on this graph. We know the center is 0, 0. We know this point right here, right? This is 1, 2, 3, 0. This point over here then is -3, 0, isn't it? 1, 2, -3. This is 0, 2 right here, and this is 0, negative 2 right there. Now, remember, this is A right here, right? And this one is B right here. A is always the bigger one. And in this case, A was under the X. So that's how we drew our graph. Now they want us, right? What do they want us to do? They want us to write down the major axis, right? What's the major axis? So when they ask us to do this problem and they want us to write down the major axis, how do they want us to talk about that? Well, we can see the major axis. The major axis is right here. It goes from here to here. So what are they going to ask us? Well, they may ask us, how long is the major axis? And how long is that? And we can look at our picture. We can see the major axis is 2A long. Right? It's A over here and A over there. How long is the minor axis? Well, look at our picture. The minor axis is 2B long. So we have names, right? We have names for the end points of the major axis. This point right here is called a vertex. And this point right here is called a vertex. Now make sure you get that in your notes, because in the homework, they're going to ask you, where are the vertices, right? Vertices, plural of vertex. The vertices are at the end points of the major axis. These points over here, they don't have a name. Don't name those. There's not 4 vertices, there are 2 vertices. 2, not 4, 2, just 2. On tests and quizzes, people write down 4 vertices all the time. Don't be that kid, right? Don't be that person. So what are they going to ask us? They're going to ask us, where are the vertices? How long is the major axis? How long is the minor axis? Right? The major axis is the longer one because A is always bigger than B. And then the one thing we haven't talked about yet, right? We haven't talked about foci. Where are the foci? Well, the foci for an ellipse are inside the ellipse. Now we say the foci, right? The foci are going to be, in this case, plus or minus C comma 0. Now that's great, if only we knew what C was, huh? We don't know what C is. I haven't talked at all about C. It's the last thing we do, so it's the last thing I'm going to talk about. So what is C? Well, how do I find C? Well, we have an equation. B squared equals A squared minus C squared. All right, now we have to remember that equation. We have to remember that. You got to write that in your notes. You got to remember that because it's the only way we can find the foci. So how do we find our foci? Well, we know what B squared is, right? Here's B. B is 2, right? We should have written that down. A is 3, B is 2. So B squared is going to be 4. That's going to be A squared, which is 9, minus C squared. Now we solve this. If we solve this, that's going to be negative 5 equals negative C squared. Don't panic. That gets me C squared equals 5. So what does C equal? C equals plus or minus the square root of 5. So if they ask us where are the foci, right? Foci are always on the major axis. Okay? And they're inside the ellipse. See, square root of 5, that's smaller than 3. The square root of 5 is right here, and the square root of 5 is right here. The square root of 5 is a little bit bigger than 2. So we know we've made a boo-boo, a mistake in our problem, if we work out our foci and they land outside the ellipse. That's bad. That's bad. We don't want that to happen. So, what are our foci on our picture? Well, we can label those, right? We know what that point is. That point is we went over the square root of 5, 0. And over here, right, our other foci is minus the square root of 5, 0. So this is how we do an ellipse. And there's a lot going on here. I'm going to do another example. Don't panic. We'll do one more. But this is what we do to answer the homework questions. It all comes down to drawing the graph first. We want to draw the graph first. And to draw the graph, we need the center, we need A, and we need B. Okay? And then we draw the graph, and everything they're going to ask us about in the homework problems is going to be discoverable once we find the graph. Right? So, let's take a look at a couple of questions that we can practice. Okay? So I'm going to erase this. Let's grab a problem, and let's look at a problem where they just ask us to do everything, right? We'll just start with one of those. So let's start with something like x squared plus 3y squared minus 12y plus 9 equals 0. And I know what you're thinking. That doesn't look anything like what we wrote down a second ago. That's okay. Don't panic. We're going to make it look like that. We're going to make it turn into what we wanted it to be. Look, we're going to do this. Watch. We're going to put the x squared here. We'll put the 3y squared and the 12y over here. And we're going to move that 9 to the other side. Okay, we're going to move the 9 to the other side. Now, that doesn't look anything like the formula for an ellipse. I know it doesn't, but that's okay. Because what we're going to do is what we did in Algebra 2. Now, complete the square. We're going to complete the square. Okay? Sometimes when we're graphing an ellipse, we have to complete the square. Now, we don't have to complete the square on x squared. We know who that is. That's x minus 0 squared. That one's already done. We can factor 3 out of here. All right, and now we're going to complete the square. You remember how to do that? I teach it this way. B equals negative 4, right? B is negative 4. 1/2 of B, negative 2, correct. 1/2 of B squared equals 4. That's correct. Now, that means we add a 4 right here. I'll change colors. We're going to add a 4, right? This goes right here. Remember how to complete the square from Algebra 2? 4 goes there. Now, 4 goes there. But we also have to balance this side. Now, be careful. This is one of those tricky ones from Algebra 2. There's a 3 out here. So we're not going to add a 4. 3 times 4. We're going to add a 12. Right? We're going to add a 12 because 3 times 4 is 12. We have to add a 12 on this side. Now what do? Well, now we factor. Now we factor. So what is this going to look like? Well, this is going to be x minus 0 squared, right, plus 3, right, 3. And then we get what here? Well, this helps us factor, doesn't it? That's going to be y minus 2 squared. And what's this side going to equal? It's going to equal 3, isn't it? Okay. Now it looks a little bit more like our formula for the ellipse, doesn't it? But this is supposed to be a 1. So we divide this side by 3, this side by 3, and this side by 3. And now what do we get? Now we have x minus 0 squared over 3 plus y minus 2 squared over 1, don't we? Because 3 divides into 3, we get a 1 there. And here we get a 1. And look at that. It looks just like our formula for the ellipse. Magic. Almost. Right? That's supposed to be a squared. That's supposed to be, these are supposed to be squared. So let's write it again. Let's write it again. Right? Now, What happens if that's not a perfect square? Well, we don't panic. We're in pre-calc. We write that as the square root of 3 squared. It's not a big deal. That doesn't turn out to be 16. We're okay. This is going to be y minus 2 squared. That's 1 squared. We're just going to make it look like our formula. Now remember, a is the bigger one. A is the bigger one. So which one of these is a? Right, we're going to make our list. A is the square root of 3, isn't it? Because that's the bigger one. B is 1. Where's our center? Well, our center, you can see it, right? It's 0, 2. Now we can draw our ellipse. We have everything we need to draw the ellipse. All right. We know where our center is. Our center is x is 0, y is 2. So let's go up here 2. All right. 1, 2. That's going to be our center. That's our center. Our center is x is 0, y is 2. Now, a is the bigger. A is under x. So our major axis is going to go in the x direction. So I'm going to take my red pen. I'm just going to draw a little line here in the x direction, a dashed line, just a dashed line like this. So that's going to be my major axis. Now, how far do I go? I go to the square root of 3. The square root of 3. The square root of 3 is a little bit bigger than 1, right? It's a little bit bigger than 1. So here's 1. So I'm going to call this the end of my major axis. Now you know what the coordinates of that point are. So do I. That's 0, 2, right? We can write that down. That's 0, 2, 0, 2. X is 0, y is 2. Who's this going to be? Well, you're right. We went the square root of 3, so this is going to be the square root of 3. We didn't go up or down, so that's still going to be 2. Now, what's our axis going to look like over here? Well, we're going to go the same way over here, right? We're going to have minus the square root of 3, 2. That's our major axis, right? That's our major axis. What about our minor axis? Well, our minor axis, we go 1. Let's use blue for that. We go 1 unit down, right? 1 unit down, 1 unit up. That's going to be our minor axis. Now, because we know our major axis and our minor axis, we can draw our box, right? We can draw our box. Our box is going to go from here over to here. It's going to go from here up to here. It's going to go from here up to here. And it's going to go across this one. This is going to be our box. And now we can draw our ellipse, right? We can draw in our ellipse. Our ellipse is going to go from here, down to here, down to here, down to here, up to here. Now, what are they going to ask us to do, right? Well, in this question, they said, find the equation and find the equation. We did that. Okay, we did that. Find the center. We did that. Find the vertices. Okay, now we haven't done that yet, but we've got them labeled, don't we? We know our vertices. Our vertices are the endpoints of the major axis. We labeled those. So our vertices are going to be square root of 3, 2, and minus square root of 3, 2. We've got those, right? Now, it also said find the foci. They want us to find the foci. Now, we don't have those labeled yet, do we? We don't have those. So how are we going to find those? We're going to use our equation. Do you remember the equation? Our equation, right? We'll do our work over here off to the side. Our equation was b squared equals a squared minus c squared. That's our equation for the foci. Who's our b? Our b is 1. So that's 1 squared, 1, equals square root of 3 squared minus c squared. Now, square root of 3 squared, of course, is just 3. Minus c squared. We're going to move the 3 over here. Negative 2 is negative c squared. C squared equals 2. So c equals plus or minus the root of 2. Now, the root of 2 is right here. It's smaller than the root of 3. So we did it right because we ended up inside of our ellipse. So our foci, right, we know what the coordinates of that point are. We started at 0. We went the square root of 2 this way. So we're root 2. We're still up at 2, right? We didn't move down or up. And then we move this way, root 2, so that's minus root 2, 2. So this is how we do our problem. And look at all the things they could ask us that we cannot answer because we've written down our graph, right? They could say, how long is the minor axis? Now remember, the minor axis is the short one. It's this one right there, right? We know how long that is. We went B this way. We went B this way, so it's 2B, right? 2B is the answer. And we know that's 2 times 1, or 2. And if we look at our graph, we can see that. All right? So this is a short video on how to do ellipses. You can read your book for additional help, right? You can go on the internet and watch other videos on the ellipse. Okay? If you're in my class, your homework from section 10.3, right? Section 10.3 is going to be, so our homework is section 10.3, number 7 through 63R. Okay, now if you're in Mrs. Tedder's class or Mrs. Rainier's class, then you're going to do the homework that they told you to do. All right, everybody have a great day.